Hey there, this is a video that walks through the use of the zonal statistics tool in QGIS. I'm using QGIS 3.16, I believe. So if you're using another version, your results may vary. So zonal statistics, just to give a basic overview, is a really helpful way to summarize the characteristics of some raster layer. Here we're looking at elevation, but it might be climate data or land cover or something like that, within some boundary file. And that boundary file can also be a raster layer. More commonly, it tends to be some kind of a vector layer. We're going to walk through that process in QGIS, but other GIS software also has tools for this as well. So what we're doing today is we want to identify the block group in the Atlanta metropolitan area that has the highest elevation. And what you see in front of you is a DEM for a digital elevation model for the state of Georgia. DEMs are always very pretty. Between the mountains and the rivers, you get very nice contours. If you zoom in, they get a little pixely, but it's still pretty good. And I've also loaded and just to highlight that, if I use my little identify tool here, if I click on it, we see that this is, hold on, about 193, 136 meters. You can see there's an elevation listed here. Up in the mountains, it's closer to 1,000 meters. All right. So, and then we've also got a block group layer. So this is all census block groups using 2020 boundaries in the city of Atlanta. All right. So what we want to do is aggregate the values for these for this DEM within each block group boundaries and see what the mean or median elevation is within each of those areas. So to do that, we need to first find the zonal statistics tool, and there's a few different ways you can do it. I can open my processing toolbox over here and either search for it, or I believe it's under raster analysis. Yes, it's right down here under zonal statistics, or I can search for it here, or I can type it down in this toolbar down here. Either way, you'll see a zonal statistics button. I'll go ahead and click on it. Oops. Right down here. And sorry, my face is kind of in the way on that, but it's right here. So we've got, it already auto-detects our raster layer, right? And that's the layer we're doing the zones on. And then your input layer is whatever the zones are defined by. So the raster layer is the values that you're aggregating. The input layer is the boundary file that you want to use. So in this case, I'm going to use my block groups, and I'm just going to use the only raster band that's available in these data. There's only one band, and then it's going to ask you for an output column prefix. That is something that in the attribute table of the result file is going to mark that there's something going on here. I'll just leave it as an underscore for now. There's a parameter here for statistics to calculate, so you can do lots of different things with that numeric data, those elevations. You can count the number of pixels, you can sum their values. If you have a dummy variable, you might want to do that, or a population variable, something like that. You can calculate mean, median, standard deviation, all these things. For this, I'm going to do mean and median. Let's see what the mean and median elevation is. Maybe let's look at standard deviation too, since we're on it. And I'll go ahead and click OK. I think that's good to go. I'll just save it as a temporary layer right now, and I'll click on Run. It'll take just a second to run through. Now I've got this temporary layer added in as a result of zonal statistics. All right, so I'm going to turn this one off. Here's my zonal statistics layer. If I open up the attribute table, I get something that looks like this. So I have some information about those census blocks and population data, things like that. And here's my mean, median, and standard deviation. So if I wanted to know which area had the highest median, I can sort. There is a block group that is 654 meters. If I right-click on this and choose Zoom to Feature, it'll identify it. In fact, let's just go ahead, and I'll this over here. I'm going to go ahead and select it. There we go. So it's this block group right here. If I wanted to see where that was, I can turn this layer off and add an OpenStreetMap layer using Quick Map Services as a plugin. So I'll go ahead and do that. And it looks like this is in Gilmer County in a wildlife management area. That makes sense. It's right at the very top end of the metro area. If I go back over here and check the zonal statistics again, let's see if it's similar for the mean. So if I calculate the mean, it's not quite the same. There's some skewness there, but it's right in that same area. So this north quadrant of the Atlanta metro is where those highest elevation values are. The area with the most standard deviation is probably kind of similar, right? In fact, I'm going to hold Control down and just select several of these. And you'll see those are all around here. So this is a really mountainy, varied kind of terrain. Last thing that's kind of fun to do sometimes, going from a DEM that tends to be pretty continuous, very much looks like kind of a raster, to something that's vectorized. We can, sometimes it's helpful just to visualize the results. So I'm going to go ahead and click on Properties, Graduated, and let's take that median value, and we'll use a natural breaks color scheme. Let's do something a little prettier than the stock. We'll do one of these, right, and click OK. And you'll see here what the resulting looks like. And you can see kind of that those areas of higher elevation, areas of lower elevation that are kind of cutting across here. You've got the foothills of the Appalachians essentially cutting across the west to northeast part of the Atlanta metro area. So that's a basic walkthrough of how to do zonal statistics in QGIS.